Hello friends, and welcome to this session. We are going to talk about the physical implementation of the data lake. Now when I am talking about the data lake in this scenario, I am very specific on the serverless data lake. It means whichever the AWS services I am going to use, it is all serverless. You don't have to think about the infrastructure. You don't have to think about the capacity planning, the scalability, performance, whether it is highly available, not available, all those concerns, don't think about it. It is all being managed by the AWS. What you have to do is start thinking about only the business, the data engineering side, the data science part, the AIM, those use cases, how can you implement them? We will start with this global data platform reference architecture. In this architecture, there are 4 lanes. Very specific 4 lane. The first lane is all about sources, what all data sources which are going to have. The second lane is the ingestion mechanism, which all AWS services which we are going to use to ingest the data from your data sources into your data lake or the lake house. The third is actually your lake house boundary. This is the swim lane which talks about the lake house thing. And the fourth is where you are going to consume this data for your different analytics use cases. I hope swim lane is all clear to you. Let's go one by one into each of these swim lane. The first I was talking about is the sources, the data sources. Now within this swim lane, within this boundary, you are seeing that I have categorized 4 different types of data sources. The reason, depending on this data behavior, you will have a very specific type of data ingestion, a very specific mechanism that you are going to apply, a very specific AWS service that you are going to select out of the many available for a specific data source behavior. And that is the reason there are 4 broad category. The first one, which is a pure SQL query kind of data. For example, if you have an e-commerce website, you are going to have your transactional data, your order data, your customer data, all those things comes under the SQL data type. If you take the example of manufacturing customers, they have got the sensor. The sensor, they capture the data, which are either the health data or the process data. Now this health data and the process data, the sensor then starts sending it to a centralized repository, which we call it as historian database. Now what is this historian database? This is a SQL database, a RDBMS. It could be any of the RDBMS depending on which product you are using there in your plant. If I take the example of even healthcare, the patient data, the electronic health record, all comes under the SQL data because generally it's a RDBMS data which you are storing there. Second is the streaming data. What is stream? It's a continuous flow of data. And how it looks like, it's like data is continuously flowing. Now take the example. The first example is the clickstream data. The name itself is the clickstream. Now how does it become clickstream? Where is the continuity? How the data is continuously flowing? It is because on the web page you have got multiple links. Now on your e-commerce site, if the user is visiting your web page, they are clicking on different links which are there on that web page. Now all those links are generating the event, and that event is going to the server side onto the AWS cloud. Now this is just for one user. Now you can just multiply it with all the other users who are accessing your e-commerce website at the same point of time. All that data, they all are going continuously to the server on the AWS side, and it looks like a continuous stream of data. The other feeds are also the social feeds. The third one, which is also comes under the stream data, which is the IoT data. You can see this is also a continuous flow of data. There are sensors, I would say, which are running inside your smart devices or which are running in the plant. So these sensors are continuously sending the data to the cloud. And this is again comes under the stream part. But why do we keep it separate? The reason, as I said earlier, it's on the basis of the ingestion mechanism. And the IoT data are ingested in a very different way because of the protocol that it uses, because of the message format that it uses. इसलिए we have kept it separate. Third is the SaaS data. I categorize it as a SaaS data, but you understand it with certain example. For example, you have the Salesforce. So Salesforce is a complete SaaS based application. It means that you do not have access directly to their database. So if suppose Salesforce is using their own database, there is no connectivity to that database. You can't connect there. So how do you connect? Salesforce exposes the API. So you have to connect to those API from your application, and then that's how you get all those data. Now, either you can write your own code to fetch the data and everything from those API, either as a batch or either as an event-based kind of mechanism, or you can use a specific AWS service for that purpose. Same thing happens with the SAP also. So SAP, it's actually not a SaaS based kind of application deployment, but SAP also doesn't allow you for a direct access to their database. This is not allowed. So in that case also, you have the APIs which are available, and then you access the SAP data through those APIs. So that is the reason that since you do not have direct access to the database like it is in case of the SQL data, that's why we have kept it as a separate bucket, and there is a separate mechanism also to fetch this kind of data. And finally, the IoT data. So IoT data, generally, IoT, there are two types of data in the IoT. One is the smart devices. You have the smart devices. You have a smart freeze, a smart AC, a smart washing machine. So those devices, they all have got a sensor. We call it also as a chipset, which takes the instruction, which sends you the data. Take the example of AC. So the sensor which is running inside the smart AC, they continuously send the data to the cloud. Same way, if you take the example of a plant, so in the plant also you have got multiple devices. So there are many devices which are there in the production line. And this devices has got the sensors. Each of them has got the sensors. And each of this sensor is sending its own data to the cloud. Now, when they are sending this data to the cloud, they generally work on certain manufacturing or industrial protocol. The most common one is the MQTT. So on the AWS side, again, there are very specific services which are meant to capture, this kind of IoT data, which are communicating over MQTT protocol. So I think you have got the gist of what are the different sources, what are the different category of the sources. So friends, thanks a lot for staying with me and going through the concept of different types of data sources. Since this whole topic is very large, so I have divided this session into 4 parts. The part 1 that talks about the different types of data sources. In the part 2 of this video, we are going to talk about the different ingestion mechanism, and in the part 3, it is all about the LakeHouse architecture, and finally in the part 4, I am going to talk about the data consumption side, the analytics side. So stay tuned with me and see you soon in the next part 2, which is talking about the data ingestion mechanism. Thank you and see you soon. Bye bye.